The default mode network activates when a person is introspective, and under normal circumstances becomes less active when a person shifts their attention to the outside world. But brain studies show that under the influence of a psychedelic, the default mode network is quieted, while other regions of the brain increase communication with each other. A mathematical model captures a normal brain's activity. In contrast, a brain under the influence of psilocybin reveals a dramatic increase in global communication. Thousands of new connections form, linking brain regions that don't normally talk to each other.
One analogy I've used for how psychedelics work in the brain is this snow globe. When you pick up a snow globe, you know, the snow's settled at the bottom, it's sort of fixed, and then you pick it up, shake it, and things jiggle around, and there's randomness and a kind of chaos, if you want, in the system.
The user experiences this as an altered and heightened sense of awareness. But what causes this?
Early in our functional brain imaging studies of psychedelics, scientists were finding that the default mode network was turning down or turning off during these experiences. And that was a really good place to start. But we began to then look one layer deeper. Why was the default mode network turning off?
New research led neuroscientist Fred Barrett to investigate a region of the brain called the claustrum.
The claustrum is a really thin sheet of gray matter in the brain, tucked deep within each of the hemispheres of the brain. Recent animal models have shown that it is incredibly highly connected to just about every other region of the brain. Understanding that the receptors targeted by psychedelic drugs are also really densely expressed in the claustrum, we began to wonder whether the claustrum may be at the center of psychedelic effects.
Fred believes the claustrum's central location and shape suggest it regulates communication between the departments.
When it's functioning normally, the claustrum is essentially acting like a switchboard. It's trying to help other brain regions figure out when to turn on and when to turn off. But when we experience a psychedelic drug, we believe that it's binding to specific receptors in the claustrum and somehow disrupting or disorganizing the claustrum. It's almost as if the switchboard walks away. What happens next is that we seem to observe a radical change in the way that brain regions talk to each other. And it may be within this context that we're experiencing learning and a possible even rewiring of the circuits that govern our behavior. And it may be that it's that radical reorganization that allows people to encounter new psychological insights that they hadn't encountered before.
Fred thinks the claustrum's sudden abdication of control may help explain why rigid behavior and thought patterns have a shot at resetting.
It's almost like they've seen this kind of grand menu within their mind that they weren't aware of, that this greater number of possibilities that they can explore.
It took a while to recover. I was having headaches and muscle pains, but it was the best headache I'd ever had in my life because it told me that the psilocybin was working. It was actually physically restructuring my brain, something that I never imagined could happen before.
It's like reprogramming the operating system of a computer. You're getting down to very basic code level changes that can enduringly change someone going forward.